Günaydın. Good morning. Pardon. So, so last Monday, the last lecture, we talked about actually introduced software architecture design. We have discussed the motivations, provide the rationale, define some or describe some definitions, okay, and looked at the influence of architecture on the whole project, etc. And today we will look at the modeling of software architecture. So this is the contents that we will use. First of all, need for modeling architecture. Why do we need to model architecture at all? Actually, modeling is a ubiquitous activity in software development. As we will see, it's also important in software architecture design. Then we will look at first at modeling software architecture in UML, and also an important part is context diagrams. That's this part. The second part will be about architecture description languages. So why do we need modeling? As I said, if you do software engineering, software development, or actually any engineering discipline, you have modeling. Why do we model things or a problem? To visualize the things before we develop. Models can be used as a guidance for the production. It can document the decisions, okay, that are made, and last but not least, for communication of our ideas. Right? One of the motivations for architecture design was, as we said, also stakeholder communication. So in that sense, also architectural modeling is important. If you look at the software development life cycle, actually consists of several phases, workflows, however you call them. In each of these phases, we develop actually artifacts, products of some process, some heuristic rules that you apply. For example, at requirements analysis, typically you would have use case models, right? And design object-oriented class diagrams. They are actually all implicitly or explicitly related, and in the end we get the final code. Okay. Again, this is not mentioned to be a waterfall life cycle, but just to illustrate any life cycle. Consists of several phases, okay, which produce artifacts which are implicitly or explicitly related. Okay. Well, if you look at the some abstract level, as we said, so typically we will start with requirements analysis and domain analysis, and then design the architecture. Realization will consist of detailed analysis and design. So I said, so in each of these phases, we develop artifacts, work products, and typically as represented as models. The requirements as use case diagram here, for example, class diagram, and also for architecture design we will have architectural model. Okay, why? Just the same motivation as for modeling in general, for visualizing the thing that we are going to develop, for communicating our ideas, for guiding the process, etc. Okay, so it's quite logical to have a software architecture model. Okay. So if you look at any system, any software system, the bottom line is that we can just say every system has an architecture. Okay. From very simple to very complex. You look at this, so we have a system that we are going to develop or is developed. This system inhabits an environment, is in some environment. The environment influences the system, and this is the idea. So every system has an architecture. Okay. So we could say, okay, it's architecture, fine. We don't represent, right? Which was also done for in the early days of software development. So we had just basically, as we said, programming, but no high-level design. But it makes sense, of course, to specify the architecture. So every system embeds some architecture, includes some architecture. So if you want to control that architecture, control the system, it's better to specify the architecture. So you should make it explicit. There we have the notion of the architecture versus specification of the architecture. So every system has an architecture, and this architecture is described by architectural description. It's a general notion, describing architecture. You don't say yet how, but we have to make it explicit in some means. Typically, this architecture provides some rationale. Okay? Why we said architecture is a means for communication between stakeholders. It includes the design decisions. So typically, when we describe the architecture, we also provide the rationale. And architectural description, how do we describe architecture? Usually as a set of models. Okay? That's the case. This is the definition of software architecture. As we have seen before, software architecture is from IEEE standard. Software architecture is the fundamental organization of a system, embodied in its components, their relationships to each other and the environment, and the principles governing its design and evolution. This was one of the definitions that we said it's a good definition, which is also cited a lot. Well, this is the definition, and we have to model the architecture. So architecture is a high-level design, gross level, representing gross level decomposition of the system, consists of components, connectors, so it's maybe guidelines. Okay, so how do we represent such a thing? So typically, you could say we just use some lines and boxes, right? We had components, component 2. So this typically represents, this informal notation typically represents some architecture. Okay. Before the, so 15, 20 years ago, even nowadays we see such kind of diagrams where they just put this figure and then say, well, this is the architecture. You've seen such things before, probably. What is wrong with this? Why is this? So we said, system has an architecture, okay, and we should model it. Why? So then we can communicate our ideas, visualize, can be used as guidelines, etc. So it's not implicit, explicit. Then we decide to model. We can decide to model in informal way. Just take any lines and boxes, ovals, whatever, enter rows. And we have such an architecture. I say, this is my architecture. What is wrong with this?
It doesn't have a standard.
It doesn't have a standard. Can you explain? What do you mean?
If we choose our representation, anybody cannot understand what we represent with boxes and lines.
Okay, if you look at this more concretely, if you look at this figure, what would you say?
Component.
Relation between components is missing. Maybe.
Sorry?
The relation between components is missing. We don't know what kind of relation.
There's a relation here, informal, but
what is the relation?
What is the relation? So what kind of relation could this be? If I would ask, maybe I would have 2 or 3 different answers. So what would it be according to you, typically?
Anything. Maybe has relation.
Has relation. What could it be else? What kind of other relation?
Anything possible.
Sorry?
Anything is possible.
Anything is possible. So does this relation reflect what it means? Here, this informal diagram? No. Right? What about the components? What do the components mean? What I've seen many of such. It could be class, package, nodes. We don't know actually, right? But you see, I have seen a lot of these figures. Currently this is getting less and less because the knowledge on architectural documentation, architectural modeling has improved. But this, so we have to model the architecture, that's for sure, but we should not model it in an informal way. Okay? So we say this is ambiguous. Okay? It can have different meanings for different persons. So confusing. I read this, this is typically a class, and this is typically a users relation or calls relation. Another person reads this as more hardware node, and this is also maybe RPC, this is another hardware node. Okay. So it's not clear. And sometimes they even mix up all these things. So it's ambiguous and leads to confusion. We don't know what the components are. Is the class? Is the runtime entity? Is this a process? Or data store? What is it? Ambiguous. It's open for multiple interpretation, and if something is open for multiple interpretation, of course you get confusion. But we said it should. It's a means for communication, so we failed there already. And we said it's a means for guiding the software development process. How can I guide the process if I don't know what these elements are? What are the relations? There's data flow, control flow, okay, dependency link, allocation, can be anything actually. Okay? So that brings us to the next step. So, system has architecture. Every system has architecture, simple or complex. We have to model it, but not in an informal way. So more formal, more precise way we have to model. Okay. Well, there are two basic means for that. So architecture description. So we have to describe the architecture. So we can describe either visually or textually. And the third one would be verbally, but that's not, it would be ambiguous because natural language is ambiguous. Visually, we can distinguish between UML-based and other more dedicated languages. And textually, we call these architecture description languages. They are just representations in text. We will look at UML-based and not other, because it's more standard. So let's look at that. What it means, modeling software architecture in UML. So why do we need UML? Why would we look at UML for representing architecture?
Visually is easy than the textual way. When we represent our diagram to our customer, maybe our partner, it's easy to show.
Good. So it's actually, so the question is also, we are going to represent in a visual manner, and you say indeed it's the right motivation. If you do it visually, it might be more understandable for the customer or the stakeholders. But in these visual languages, why would you go for UML?
Sorry?
Why would you go for UML and not another visual language?
Because it's a standard way between all the partners or your friends. So you choose this way.
It's a standard language. It's one of the key motivations, right? It's a de facto standard, we say. It's a general purpose modeling language, supports diverse application areas. When we design architecture, we have usually to look at different domains. It's based on experience, so it's consolidated. It's widespread use, not only in software design, but also recently, relatively recent, also in system engineering, like UML, and now we have SysML. It's a profile of UML, supported by many tools, of course. It's a standard, but we have also many tools which are based on UML meta model. And it supports the entire software development life cycle. If you want to have alignment with your design, then it makes sense to have and if the design is in UML, it makes sense to look also at UML to represent architecture. So it's a clear motivation, actually. So it makes sense. So how can we model in UML architecture? Well, for that we have to look at the UML itself. Actually, there are three approaches. Either we use the UML models as is, we say, we just take the notations as described in these textbooks and try to represent the architectural components and relations. Second approach, we use UML's built-in extension mechanisms to refine the existing models. I will explain this. So UML is not it's a general purpose language, but also includes some extension mechanisms to provide more dedicated modeling. The third one is use UML, but introduce new abstractions, new notations to UML. So actually it means that we need to extend the grammar, the meta model of UML. Basically three approaches. Okay? Let's look at these three approaches. First of all, use UML as is, which means you just take the UML textbook on UML, which describes the notations or representing the design elements. And then you are going to check how you can represent architecture using these notations. So typically we have to answer two questions. What are the candidate UML models for representing architectural components? What are the candidate UML relations for representing architectural relations? It's very simply stated. If you just say architecture consists of components and its relations, then we need to answer these questions. How should I represent architectural components? How to represent architectural relation? Right? Well, you know actually from the course Object-Oriented Design, architectural components is a structural component, structural element. So we have to look at the structural elements in UML. Basically there are four types: classes, packages, components, and nodes. Right? These three basically represent software elements, and this is more hardware element. But you could say, well, these are the candidates. So to represent my architectural components, I can choose among these. Okay. Then the second question, what are the architectural, how to represent architectural relations? Well, for that we can look at, again, the relations in UML. We have aggregation, composition, association, dependency, generalization. Okay. You have seen this in the course on Object-Oriented Design. Okay, it's just detailed design. Now we say, how can I use these relations to represent architectural relations? Okay. So, now, UML as is, then we are going to select from these, from the existing structural elements and relations. Then we get this package. So I can say I'm going to select for example, classes and the relations here to represent my architecture. Or you can say I take packages or nodes, etc. Okay. Example: architecture components as packages. This is a transaction system architecture, which has been which we have developed before, actually in a project with Siemens Nixdorf. Typically, in this case, so the architecture components are represented as packages. We say architecture components here. The idea was it's cross-level structure, so it's a kind of grouping. So we have an element transaction manager, architecture component, architecture component data manager. So as you see, it's just we haven't changed anything to UML. We have just taken the packages and represented our architecture, and we say this is our architecture. What do you think of this? Any problems with this? You could also use class. So problem here is, what are packages? It's like subsystems. The notation, by the way, has changed a bit in UML too, but that's a detail. Packages are just grouping mechanisms, grouping constructs. It just says the set of elements belong to the same group, and we call it a package. For example, in this case, it means like we have a data manager grouping where we have elements related to data management. But we said, okay, architecture is not just structure, right? It can also have semantics. We might need to define the operations, our attributes, constraints, etc. And for that, using packages to represent architectural components in general sense is not sufficient. I cannot define semantics in the package, right? It's just grouping. So what would you then, if you want to add semantics, operations to the architectural elements, what would you then advise to use? We are now in the first category still. Use UML as is. Which element would you then use? So we had 4 elements, right? In UML: class, component, package, node. There are 3 left, so you select one of them, A, B, or C. So what about if you take classes? This is the architecture, the same architecture we now represent as classes, using class diagram. What's the distinction between this and this? Well, we can add additional information. We said our architectural component is just a class. If we borrow the class element, we have the means to represent attributes and operations. So we can add additional semantics to the architectural components, which is not possible if we use packages, right? Because packages are just grouping mechanisms. The problem here is, imagine we are working in a project. It's very difficult to distinguish this with the normal class diagrams. Just looks like detailed design, but our intention is to represent as high level pressure. Something is wrong here. Too enthusiastic. Test. Okay. So if you say I want to explicitly represent architecture, then this is also not sufficient. That's the second approach. That brings us to the second approach. So the first approach was just use UML as is. Don't care about any extensions. Second approach is it's again using UML, but in the second approach we use the built-in extensibility mechanisms of UML. There are three types: stereotypes, tagged values, and constraints. We say so. UML is a general purpose language, but it also represents a family of languages. So it represents some core elements, but also extension mechanisms which can be used to customize somehow the existing elements. Customization for different purposes. Okay. And there are three different elements that you can use. Let me explain this with an example. There are two classes here, as we see: overflow, event queue. In this application, we have event queue. We add events to the queue, right? And if we get some overflow, this overflow class object is called. Here we see actually three different mechanisms. A stereotype, which defines existing models to define new notations. In this case we say this is overflow class, but it's a specific class. Okay. It is used to handle exceptions. We explicitly denote with this. So we have just borrowed the same element, class element, but we have stereotyped it with exception. This you can define yourself to explicitly define that it's something different. It's not just an ordinary class. It's a class which handles exceptions. Another one is tagged value. It's kind of properties. Here it stays version, author. So we have tagged this value to a class element. Why? To add some additional information. So in this case, we were interested in the version. This is in the project version 2, and the author is BT. Okay, we could add other values as well. Okay. Third one are the constraints. If we add events to the event queue, we say they should be ordered. We cannot specify this by just using operations, but we can specify by defining constraint. Here, by putting here ordered, which indicates, well, if you add the event to the queue, this queue should be ordered. Okay. So we have these three mechanisms to take existing UML elements and customize these. Okay. So how would you use these to represent architectural elements? Let me go back. This should be quite easy, right? You can stereotype, tagged value, constraint. And stereotype you can define yourself. So I want answers. So how would you do? How can we use this approach to represent architectural components? So we said in the first approach, we said we just use SS, class or packages. But we said in packages were just grouping mechanisms. Classes, it's okay, we can add additional semantics, but we want to distinguish between design and architectural design. So to customize some elements, we can use these three elements. We can stereotype, add tagged values, or constraints. So the question is, how can I use this approach for architectural modeling?
This approach is not semantics, so it's more useful.
But how? Mechanism. Anybody answers? It is useful. So I take the class element. What should I do? Come on, force your brains. How do you modify? By using stereotypes. What kind of stereotype? How would you call this stereotype?
Yeah. Maybe we can indicate that it's architectural component and
Ar-
element.
How do you indicate that something is here exception? You say exception. How do you indicate that some element is architectural?
You can just simply write it.
Simply write architectural. Yeah, it's that easy. Nothing to look at. Surprise, surprise, right? Quite easy. It is useful, but this is just a mechanism. You can just say architectural, conceptual, whatever. You can use any notation, any stereotype. Because use stereotype. The only constraint is you have to take existing elements. So you can stereotype existing elements. So arc, transaction manager, policy manager, data manager. The arc or architecture, we could state equally, is a stereotype and corresponds to an architectural abstraction. And we have the decision can we stereotype packages? Yes. Can we stereotype components? Yes. Actually, any element. So what did we say? UML is a general purpose language plus some mechanisms to customize the language. So in that sense, they also say it represents a family of languages. And these are, so what are the extension mechanisms? Stereotype, tagged values, constraints. And we are interested in modeling architecture. We say we are not happy with the existing, but we still want to use UML, so we take the class, in this case, and stereotype. This would be the result of the same architecture. Again, the same components, transaction manager, data manager, application, the same architecture, but now we have said it's architectural, stereotyped. Okay, clear. First approach we use as is. Second approach, use the elements but customize using stereotypes. Third approach, you could say, I don't want this class notation or package notation or abstraction. I want to introduce my own dedicated architectural component. It's a different abstraction than just class or package. The package doesn't represent architectural element, no component, no. So you say it's a different abstraction. I want to add a new notation, new element to UML. So we are still working with UML. What does it mean to add a new element? So UML, we say it's a unified modeling language. Language has a grammar with specific words, terminals, non-terminals. Actually, if you want to add a new element, it means that you have to change the language, right? It's not just using the extension mechanisms like stereotypes. No, you just say, I want to add a new abstraction. For that, we say updating the meta model is necessary. Meta model representing the language. So what does it mean? Very concretely, this could be a funny component that you could say, this is my architecture. It's just to distinguish between the others. So you have UML models, class, use case, packages, but you say, I don't want to use any of them. I add my own architectural element. So actually what you do is, you have UML, you add a new element. So like this is part of the UML meta model. Like, it's just part. So classifier can be an interface, a class, a node. Node consists of components. And so this is UML meta model. What would it mean to add a new architectural abstraction in this picture? What does it mean? So we have to change the language. We are going to add something. So we have to change the meta model. So we have to change this actually. How would you typically represent an architectural component here? So you are now the UML designer. You are going to represent architecture, architectural element. Okay, so here they say classifier, so you have interface, class, node, component, and we add another architectural abstraction. So what can you typically do? Just give me an example. You could say I extend this model in this way. What can you do? Think and think aloud. How do you do? I have a component architecture. I have to add it somewhere, right? Somebody, yes.
There is a relation we can connect them to components.
This could be just an example. You could say, okay, these are is the language of UML. Okay, they have a node component class, but I want a different element, which means we say we have to change the meta model, change the language. Typically, it could be like this, right? You could say architecture component is a classifier. Okay, just an example. So, but it means that you have to change the UML meta model. This has actually, of course, a huge impact. You will see that. But let's look at the impact on the second approach on meta model. This was this in the second approach we use stereotypes. Does it have an impact on this? Does it have impact? We said UML is language plus extension mechanism, and extension mechanisms are in the language itself also. So the second, what does it mean? So it means the second approach, so the stereotypes approach, does not have an impact on this, because it's in the language we said. So it's in the meta model. So like this. So if you have this is the first approach, we use as is. The stereotype class, we actually borrow the class element, which is described in the meta model. Like here, sorry. Here's the class. We use that. We can just use as is, but we can also stereotype it, and we said this mechanism is also in the language. So does it have an impact? No. It has no impact. It's just the same in the first and second approach. In the third approach, we said it changes, right? We added another architectural abstraction, an element, we subclass from classifier. We change the language actually. This is the meta model. We added another element. The meta model will change, and of course the model will be in the models. We don't have stereotyped classes, but specific elements which represent architectural components. It's clear? Okay. So why is this, before we go on the comparison, why is this the third approach? Is it not preferable? Why is not preferable? Oh.
It may lead to confusion because it's our specification and others someone look at.
So you actually define a new dedicated approach which others might not understand. I mean, that's a motivation why this is not preferable. Another one. So in the project you use tools, process, design. So what would be why is this not preferable? For example, from tools perspective.
Every tool cannot support this kind of representation.
Of course. So most of the tools also adopt some language, right? UML meta model. They know the elements, class, packages, nodes, etc. And they provide means to visualize these. Now you say I want to change the meta model of UML. Fine, go ahead. But the tools cannot represent it. Okay? So incompatible with the tools. Confusion with existing. So with legacy, usually many companies do not start from scratch. They have already lots of design. And if you add another element, it could be confusing. It's also not compatible. Okay, let's compare this. So if you use UML models as is, it's compatible with UML compliant tools, but we can say it's violation of architecture component element, which means it's just like detailed design. Okay, we can use built-in. Here we could use classes or packages. Packages are grouping mechanisms, in which you cannot define semantics easily. For that, classes are better, but still both violate architectural. Do not provide native support for architecture. Here, the second approach was use built-in extension mechanisms. Here, we don't change the UML meta model at all. We just borrow existing elements, we just stereotype, and that's it. The only thing that you need to do here is to define the style specification. What do you mean by architecture? In UML 1.star was quite informal, but here UML 2 there are more formal ways to do that, but you have to do that. The third approach, you extend the meta model of UML. An advantage could be you have a completely dedicated native support for architectures, for components, elements, configurations, but it requires backward tool compatibility. It might result in confusion, which means incompatible UML versions. Any questions about this? It's clear? So we have looked at every system has architecture. We should model it. We should not model it informally, but in a more precise way. We can model it in visually or textually. If you do visually, it makes sense to use UML because it's standard, general purpose, etc. And if you use UML, there are three approaches: use SS, use extension mechanisms, or extend the language. Usually, people tend to go for the second approach, where they stereotype the existing elements, because you have full compatibility with the tools, and still possible to explicitly define the architecture, distinguish the architecture from detailed design. The third approach is quite cumbersome, very expensive, can lead to confusion and high cost. Okay, let's break now and we continue with context diagrams.